Welcome back. In this module, we're going to learn about implicit differentiation. For any function, the relationship between its dependent and independent variables can be expressed either explicitly or implicitly. The function is written explicitly when the dependent variable is the subject of the equation. Briefly study the following examples. In contrast, a function where y is not the subject is said to be written implicitly. Here's a good example. Although straight lines are typically expressed in the gradient intercept form, that is, y equals mx plus b, it is sometimes expressed in the implicitly written general form, ax plus by plus c equals 0. Here's another good example. The circle of radius r, centered at the origin, implicitly defines two functions, the upper and lower semicircle functions. You should know that these two particular implicitly written functions can be rearranged so that they are written explicitly, which is not always true. Indeed, it is impossible to rewrite some implicitly written functions so that the dependent variable y is the subject. Whether a function is written implicitly or explicitly is important to its differentiation. Specifically, your prior experiences should have taught you to always rearrange a function into its explicit form before attempting to find its derivative. For instance, the implicitly given function, 3x squared minus y equals 1, should first be rearranged to make y the subject, before working out its derivative. But it may be difficult, or perhaps downright impossible, to rearrange an equation to make y the subject. One such example is the implicitly written function x to the power of 4 plus y to the power of 4 equals 2xy. But if we can't isolate y, how can we then work out the derivative dy dx? The answer is to use the method of implicit differentiation, where we differentiate both sides with respect to x, before rearranging the new equation to make the derivative dy dx the subject. Let's demonstrate the method on the following example. Firstly, let's briefly focus our attention on the term y to the power of 4 on the left-hand side of the equation. The chain rule can be used to differentiate this term with respect to x. Moving on to the term 2xy on the right-hand side, we can use the product rule to differentiate this particular term. Hence, differentiating both sides of the equation with respect to x gives the following, where in the previous slide, we worked out the derivatives of the terms y to the power of 4 and 2xy. We can then rearrange this equation to make dy dx the subject, therefore completing the differentiation. Alright, time to have a go at the following practice question. Note that in addition to employing implicit differentiation, you will also need to evaluate the derivative at a specific point. And here's the solution. Differentiating both sides with respect to x, using a combination of the product and chain rules, we obtain the following. Rearranging the equation, we then get the derivative dy dx to be negative y divided by x. Finally, the derivative at the point minus 3, 2 is therefore 2 divided by 3.